Solve this, the first thing we want to do is we want to isolate the square root. So right now we've got this square root here, but we've also got this minus 3x. So I'm going to move that 3x over. Okay, and now I want to square this whole side to get rid of the square root, and so I'm going to square this whole side. Whatever you do to one side, you have to do the same thing to the other side. So these essentially just cancel out, and I'm left with 5x plus 4. 3x squared, you need to be careful here. 3x squared is really 3x times 3x. So it is 9x squared. People have a tendency to want to put 3x squared, but you have to square the 3 as well. There are 2 3's there, not just one. And now I want to solve this. Well, it looks like this is a quadratic, so I'm going to move these two terms over here so I get 0, because we can only solve quadratics when they're equal to 0. And I'm hopeful that this will factor, because if it factors, I do not have to use the quadratic formula. So to get 9x squared, I'm going to try 3x and 3x. And then 4, well, let's see, if I do 2 and 2, then I'm going to have all the same numbers, so this would cancel out. So that's not going to be right. If I do 4 and 1, I'm going to get 12 from here, and 3 from here. And 12 and 3 won't get me to 5. I wonder... I think there's another way to get 9x squared. What if I try 9x and 1x? What if I try that? So that's going to be 9x squared. That is going to be 9x, and that's going to be 4x. And it looks like if I do a 9x and a 4x, I can get to that 5 right there. So I think I see that this is a negative 4, so I know that these signs are going to be one positive and one negative. And I know to get negative 5, I'm going to need to do negative 9 plus 4, or you might think of it as 4 minus 9 if you're on your number line. If you start on 4 and you subtract 9, you'll be over here in the negatives. So 4 minus 9 is going to get me to negative 5. So I want to do a positive 4, so positive 4x. Now if I put the minus here, that'll give me my minus 9. You can check this, right? You're going to get 9x squared first, and then you're going to get minus 9x plus 4x minus 4, and that does give you the negative 5x. So that's it as far as we got it factored, but now we need to finish solving it. Remember when we solve a quadratic, we set each of these factors equal to 0. So I'm going to do that right up here. So I'm going to set 9x plus 4 equal to 0, and I'm going to set 1x minus 1 equal to 0. This one's the easiest one. I'll do it first. X equals 1. That's a possible solution. If I solve this, I'm going to subtract 4 first, and then I'm going to divide by 9, so x equals negative 4/9. That's a possible solution. But remember that when you have these when you end up squaring things, sometimes you end up creating a solution that doesn't end up working, so you always want to plug it back in and check to see if it works. Let's just plug it in on, well, we can do it in our head. If I plug in a 1 right here, I'm going to have the square root of 5 times 1 plus 4 minus 3. And I want to see if that gives me 0. 5 times 1 is 5, plus 4 is 9. So 3 minus 3 equals 0. That one works out. That one's just fine. So x equals 1 is a good solution. If I try to do the same thing with negative 4/9, I know it's a fraction and it looks a little tricky, but you can figure it out without a lot of headache here. And I'll show you how you know that this is not going to work. When you take the square root of something, regardless of what this number is, you need to, the square root of something is going to be positive, right? You're never going to take the square root of a number and get out a negative number. So this is going to be a positive number. And then right here we have a negative times another negative. So this is going to be a positive number. So if you take a positive number and add it to another positive number, is there any way that it can equal 0? And the answer is no. So this is what's called an extraneous solution, which basically means we created an extra solution somewhere here when we squared it, and it doesn't actually work when you plug it back in. So the only answer to this problem is x equals 1.